Hello, how are you all? This is Tahmina Khan. Today I will explain the sketch of absolute valued function. How it is defined. Let's see that. When the function is given in this modulus sign, it is called absolute valued function. Because I'm covering here the concept, the level of the concept which comes in the 11 Add Maths Cambridge CIE exam. So two types of functions come here, linear and quadratic. So we will look at the sketch of those two graphs in a little while. Before that, we will see what does this modulus do. Now, if you see here, the number 3 and minus 3, they have the same numeral value, which is 3. So the absolute value of a number is denoted by this symbol. Thus, if we have a modulus of 5 or modulus of minus 5, the value of this will be 5. Now, how we get this V-shaped graph? Let's see an example here. For example, the function is this. Let me take few values of x and let me plug in here. When I take x0, 1 or minus 1, over here I am substituting. You can see my answer is coming 1 and 1 because modulus of 1 is 1, modulus of minus 1 is 1. Then I am taking x2 and x minus 2 in the same function. So now again I am getting answer plus 2. For x plus 2 and x minus 2, my corresponding values are 2. So modulus is just changing this negative values into positive. So if I see the sketch of this graph, it will be like this. For x0, y0, for x1, here x1, y is 1, x minus 1, y is 1, minus 1, y is 1. So this is the sketch. That's why we see or we get V-shaped graph. Now let's go and explore linear and quadratic absolute valued function. Now, here I have taken an example. Like I said, absolute valued function we will sketch for linear function and for quadratic function. So for the linear function, I have taken an example of this curve, this function. This is linear and I will sketch it for the domain minus 2 to 3. So whenever we are sketching absolute valued function, we always find out the vertex value first for linear curve. This is a linear. We have seen the graph will be V-shaped graph and the V pointed end is called a vertex. So whenever we have to sketch, we find the vertex first. To find the vertex, the technique is the function which is given inside the modulus, put it equals to 0 and get the value of x, which is minus half. So now x will be minus half when this will be 0. It means your y value will be 0. So this is your vertex point. Now, because I have to sketch this graph for a particular domain which is minus 2 to 3, I will find out the corresponding value at x minus 2 and at x equals to 3, which I have found over here. So I am substituting x minus 2 in this function over here and I have found the value 3. So my another point is minus 2 comma 3. Now I will find out second point which is at x equals to 3 and here I am finding 7. So my other point is 3 comma 7. So now we have 2 points here, 2 points and one vertex. So with the help of this we will sketch a curve. So here is the curve which I have sketched for the points I have just shown to you. And if question says find out the range of the function, so what you will do, you will only find out or see the maximum and minimum point of y value, maximum and minimum values of y, that will give your range for the function. So here is the range. Now one thing, if the function has plus 3 or the function has minus 1, there is another way of sketching it, but I prefer that the student sketch this graph and then move it 3 units up. For example, I have done it over here. So you can see the graph has moved 3 units up. Now in the second case, this graph, which is modulus of 2x plus 1, has minus 1. It means now this graph will go 1 unit down. So here I have shown it. Mostly students have this misunderstanding that absolute valued function can never go below the x-axis, which is not right. So if the function has value outside the modulus, it depends on it. It will go below the x-axis or above the x-axis or either halfway. So it all depends on it. But only the modulus function will be above the x-axis. This is like the translation of it. Another concept here, which is very rarely given in the book, but it is asked in the exam, and the concept is the same modulus function which we have just drawn up has a negative sign here. Now, if I have to sketch it for the same domain, which was minus 2 to 3, for the vertex I will do exactly the same thing. So my vertex will be this time minus half 0, which was like earlier. And then I will substitute the value of x minus 2 and 3 in the function, and I will get negative values this time. Why? Because there is minus sign outside the modulus. So now what will be the impact on the graph? The graph will be upside down like this. So graph will be below the x-axis this time. So if there is a negative sign outside the modulus function, the linear graph will be inverted V. Now let's see here an example of a more absolute valued function which has a quadratic function inside. Now there are 4 steps which you have to follow. In this case, I have taken a complicated question which can cover all the concept we need to tell the student while he is learning the sketch of absolute valued function. Now this function is given like this, and I have rearranged it because this will tell me how many units I will move it up and down. So let's see step number 1, and I will sketch this graph again for the domain minus 2 to 3. So what is the step number 1? Step number 1 is that you will pick up the quadratic function which is given within the modulus, and the way you have sketched it in chapter 4, which is quadratic equation and expression, you will change this quadratic function into completing square form. And from here you will sketch it. Forget about the modulus, forget about minus, forget about 3. Just pick up this quadratic function and sketch it exactly the way you have done in chapter 4. So my turning point is 0, minus 2 because it is in the completing square form. And then I am substituting in this function, in this completing square form, or in this one, I am substituting the domain minus 2 and 3 and getting the corresponding value. So my answer is coming minus 2 and 2, and other answer is coming 3 and 7. So I have 2 points, minus 2, 2, 3, 7, and a turning point which is 0, minus 2. So I will sketch a graph on these points. Now here is a graph. It was 0, minus 2, minus 2, 2, and 3, 7. So this is a simple sketch. So according to the first step, I have sketched my curve equation of the quadratic function. Now step number 2. Step number 2, I will consider the modulus around the function. So what does modulus do? Changes all the negative values into positive values, right? So what I will do, the part of the curve which is below the x-axis, I will reflect it in the x-axis. So my curve will look like this now. Okay, so this part which was earlier below the x-axis and it has negative values of y, now because of this modulus, it will be reflected above the x-axis. So this is the curve of this part. Now, then comes the third step. The third step is there is a negative sign outside. Now what does this negative sign do? Negative sign will reflect the whole graph in the x-axis. Means all the values of y which I have here will become negative now. So this part will come here, this part will come here, this part will come here. So this graph will look like this. Let me sketch it here. I left it. I said I'll sketch it when I will be recording the video so that you can see how I'm doing it. So it's not very perfect, but anyway. So now this is my graph of step number 3, which is because of negative sign, this one below one. So now let's see what will happen when I have plus 3 here, which is step number 4. Now here comes step number 4, which is plus 3. So what plus 3 will do, it will move the graph 3 unit up, just like it happened in the linear graph. So this was my graph, and the important points were 1, 2, 3, 4, 5. So this was at -2, it will go at 1, it is here. It was at 0, it is going at 3. This was at 2, it is going at 1. This was at y-axis, y-coordinate 0. So now it is going at 3. So I have moved the whole graph 3 units up. So this is the final form of the graph. So all these steps which are doing before that should be erased when you're finally submitting your questions. And if somebody asks you what is the range of the graph, the highest value on this graph is 3 and the lowest is -4. So at the end I will repeat, when you have a modulus absolute valued function of a quadratic, step number 1 is sketch quadratic for the given domain, just like chapter 4. Then because of modulus, whatever the part is below the x-axis, reflect it in the x-axis. Then because of this minus sign, the whole graph will be reflected in the x-axis again. And then because of this plus 3, move the graph 3 unit up. Thank you very much for watching the video. And if you have any other concern or question that I should explain that concept, so please write down in the comments or send it to me on my email, which is tehminakhan25@gmail.com. And if you like the video, you think you have learned something from it, so please press the button of like and subscribe so that my new videos you can get a notification immediately. And please share the videos with other students. I hope it will be beneficial for them as well. Thank you very much for watching the video.